Okay, today we're going to be looking at some more trig functions and right triangles, sine, cosine, tangent. Number 1, find the values of trigonometric functions for angle theta, simplify all fractions. Okay, so kind of like the same thing we were looking at yesterday. So here's angle theta, it's a right triangle. We want to know what the sine of theta is, cosine of theta, and tangent of theta. So we have, remember, so, ka, toa. Sine is opposite over hypotenuse. Now you'll notice that we're actually missing our hypotenuse here. So, because this is the opposite side, this is the adjacent side, and this is the hypotenuse, and we're missing our hypotenuse. So we are going to have to calculate that using the Pythagorean theorem. A squared plus b squared is equal to c squared being the hypotenuse. So we got 144 plus 16 squared, which is 256, equals c squared. That's 400 is equal to c squared. Square root both sides, so c is equal to 20. So our hypotenuse here is actually 20. Alright, now that we have our hypotenuse, this should be a lot easier. So opposite, sine is opposite over hypotenuse. So the opposite side is 16 over the hypotenuse 20. Simplifies to 4 over 5 because they're both have factors of 5, or 4 I mean. Cosine of theta, cosine is the adjacent side over the hypotenuse. So the adjacent side is 12 and the hypotenuse is 20. These both have factors of 4, so 3 over 5. And then tangent of theta, tangent is the opposite over the adjacent. So opposite is 16, adjacent is 12. These both have factors 4, so this simplifies to 4 over 3. Number 2, find the values of the trigonometric function for angle theta. So angle theta is right here. Here is the opposite side, here is the hypotenuse, and here is the adjacent side. Unfortunately, we do not have the adjacent side, so we are going to have to solve for the adjacent side. So we're going to use the Pythagorean theorem. So a squared, this will be b, plus b squared is equal to c squared, so 1 squared. Okay, so this is square root of 3 squared over 2 squared, plus b squared is equal to 1. Okay, so that's just 3 over 4 plus b squared is equal to 1. Alright, so solving for b squared, so we subtract 3 over 4. So b squared, so 4 over 4 minus 3 over 4 is 1 over 4. Square root both sides. So we get b is equal to 1/2. So this side right here, the adjacent side, is 1/2. Alright, so now we can find the values of the trigonometric function. So we'll start with sine theta. So sine theta, that's, so remember, so, ka, toa, sine theta, that's opposite over hypotenuse. So the opposite side, square root 3 over 2, and the hypotenuse is 1, so that would be over 1, or divided by 1. Which isn't going to change it, so it's going to stay the same, square root of 3 over 2. Cosine theta, which is adjacent over hypotenuse. So the adjacent side is 1/2, and that's over 1, so it's just going to stay 1/2. And then tangent theta, that's opposite over adjacent. So the opposite side, square root 3 over 2, divided by the adjacent side. So I'm actually going to write it this way. Instead of putting it over 1/2, I'm just going to put divide by 1/2. And that's going to remind me that, whoops, that I need to multiply by 2 over 1. The factors of 2 in the numerator and denominator cancel. So that's just the square root of 3 over 1, which is the square root of 3. So tangent of theta here is the square root of 3. Find the values of the trigonometric function for angle theta. Okay, so once again I'm missing a side. So I'm going to do 5 squared plus b squared is equal to 7 squared. So 25 plus b squared is equal to 49. Subtract 25. B squared is equal to 24, it looks like. Square root both sides. B is equal to the square root of 24, which that can be written as square root of 4 times square root of 6. So b is equal to 2 square root 6. So this side right here, 2 square root 6. Alright, so this is the opposite side, this is the hypotenuse, this is the adjacent side. So we'll start with sine theta. So remember, toa, opposite over hypotenuse. So the opposite side is 5, the hypotenuse is 7, so sine of theta is 5 over 7. Cosine of theta is adjacent over hypotenuse. So the adjacent side is 2 square root 6, and that's over the hypotenuse, which is 7. So 2 square root 6 over 7. That can't be simplified. And then we have tangent of theta. So that is opposite over adjacent. So the opposite side is 5. The adjacent is 2 square root 6. Now, this is the answer, but it's not simplified. It's not simplified because you cannot have a radical in the denominator. So we'll get rid of that radical in the denominator by multiplying by square root 6 over square root 6. So that gives us in the numerator 5 square root 6. In the denominator it gives us 2 times 6, which is 12. So 5 root 6 over 12 is the tangent here. Alright, number 4. In a right triangle, angle B is acute, and the cosine of B is 3 over 7. Find the value of tangent of B. First, draw the triangle. Okay, so let's draw the triangle. It's a right triangle. We'll just call one of these angles, they're both acute, because acute just means that it's smaller than 90, so I mean it's got to be acute. I don't know how this would be a right triangle and it wouldn't be acute. So this will be angle B. Okay, so we know that cosine of B, which is cosine, so toa is adjacent over hypotenuse. So we know that the cosine of B is 3 over 7. So the adjacent, let's label this. So this is opposite, this is adjacent, this is hypotenuse. So the adjacent side is 3, the hypotenuse is 7. So we're missing the opposite side. So we'll say 3 squared plus b squared is equal to 7 squared. So 9 plus b squared is equal to 49. Subtract 9, b squared is equal to 40. Square root both sides. B is equal to the square root of 40, which can be written as square root 4 times square root 10. So 2 square root 10 is the missing side. So over here, the opposite side is 2 square root, is 2 square root 10. That's the opposite side. Okay, so now we can figure out the tangent of B. because the tangent of B is opposite over adjacent. So the opposite is 2 square root 10, the adjacent is 3, so 2 square root 10 over 3, and that is simplified. So our tangent here of angle B, 2 square root 10 over 3. Number 5, in a right triangle, angle A and angle B are acute. I mean, obviously. Acute means it's smaller than 90 degrees. I mean, there's no way for it to not be acute if it's a right triangle. So you got angle A, you got angle B. I guess essentially what they're telling us is that angle A and angle B are not the right angle. So that's what they're trying to tell us with it being acute. Alright, so we know that the tangent of A is equal to 7 over 12. So, but remember the tangent is, so katoa, opposite over adjacent. So that's 7 over 12. So if we're looking at angle A, this is the opposite side, so that's 7. This is the adjacent side, so that's 12. So we want the hypotenuse. So we got 7 squared plus 12 squared is equal to c squared. 49 plus 144 is equal to c squared. So we got 193 is equal to c squared. Square root both sides. C is equal to square root of 193. I think 193 is prime. Honestly, I don't think 193 is divisible by anything. Yeah, 193 is not divisible by anything, so it's prime there. So that can't be simplified. So this hypotenuse is square root of 193. Alright, so we want to know the cosine of A. Okay, so that's A. So for A, this is the opposite side, this is the adjacent side, and this is the hypotenuse. So if we want the cosine of A, we want the adjacent side over the hypotenuse. So the adjacent side is 12. The hypotenuse is square root of 193. Now remember, you can't leave it like this because your denominator is a radical. So we need to multiply by square root 193 over square root 193 to rationalize that denominator. So in the numerator, we have 12 times the square root of 193, and the denominator, we just have 193. And remember, 193 doesn't factor into anything, so 12 and 193 don't have anything that can factor out to cancel. So our cosine of A is 12 times the square root of 193 over 193. Alright, and here is our assignment.